Free fall. Free fall is a special case where an object in midair is acted upon only by the force of gravity, its weight. We have the formulas from lecture that y, the height, and v, the velocity, are these given functions of time. Now, the velocity is actually a small change in height over a small change in time. And we'll have to know that when to calculate from some data. Now, the data we'll collect involves, we'll see an object shot in the air, and we will be able to notice the height that it's located at various times. Now, as you can see, this happens so quickly that I will slow it down, and I'll also show the time, so you'll be able to match up times with heights. And there you have it. So we see a counter for time, and we see a sort of a ruler, and the object being launched in the air. And so at various heights, you'll be able to pause the video and make note of the time. Now, we'll use two methods to determine g. One, we'll use the height data. And at heights, on the way up, 1 meter, 1.5, 2, 2.53, and then on the way back down, 3 again, 2.5, 2, 1.51, right? At those various heights on the way up and down, just make note of the time and fill in the table. Then in Excel, you can graph height as a function of time and include a trend line that's a polynomial of degree 2. And from that, you'll be able to determine g by comparing your trend line to the formula for y we saw earlier. Now, for the second method, we'll use the same heights and times we determined earlier, but at those locations, we'll calculate the velocity. And I'll show how to do that by way of an example. Now, the velocity is a change in height over a change in time, but that change in time has to be small. We're going to learn that as a graph, velocity is the local slope of the position graph. So, for example, if the object was on the way up and it crossed the y equals 2 meter mark, which is the middle mark of the 3 marks I show those lines, and I want to calculate the velocity when y is 2 meters, I would notice the height about 1.5 or more tick marks below, and you just want to be close, but not too far away, but it'll be hard to do this. So I sort of stopped the earlier animation, and at 1.84 meters, I noticed the time was 0.245 seconds, right? And that was about 1.5 tick marks below y equals 2. Then at between 1 and 2 tick marks above y equals 2, I actually tried this. I paused the video, and at 2.15 meters, I had the time as 0.31 seconds, right? So I have, for my y equals 2 meters, where I want to know the velocity at 2 meters, I'm looking at times just before and after when we were at 2 meters. And that gives me these points y1 and y2. It's like initial and final. So when we do delta y over delta t, delta is final minus initial, right? So delta y is 2.15 minus 1.84, and delta t is 0.31 minus 0.245. And that lets me calculate the velocity, which again is the local slope of the position graph. The velocity as 4.8 meters per second. We'll round off velocity to the 10th place. And notice that on the way down, you can have negative velocities because we're taking the y-axis as up. And so with that calculation of velocity at 2 meters, we would put that in the table, and that was on the way up. And just for the rest of the heights and times that you had earlier, you would then, look at the video and do a similar calculation. You would look for a point just before and just after you crossed that height. Make note of the time difference and the height difference, and calculate the velocity, and then fill out this table. Then you would graph the velocity as a function of time in Excel and include a trend line that's linear. And in that case, the slope of the trend line will be essentially let you calculate G by the second method. And there you have it. So there's 2 data tables and 2 graphs. The first is height and time data, and a graph that's height versus time with a polynomial degree 2 trend line. And the second table has heights and times and your calculated velocities. And the graph is velocity versus time, and you're including a linear trend line to determine G in each case. Assignment details will be posted. See you all in class.